So our next stage, looking at how it's going to go. So we've got our ship there again. There's Tug A. There's Tug B with our 25 degrees separation. So we're looking at Tug B now. So again, we'll just write Tug B. And I'm going to redraw that graph that I had so it's all a bit clearer. So we've got our Y positive, X positive, negative X and negative Y. And there's our line representing Tug B. Now as before, we wrote Tug A's 75 newtons along the direction it was going. Tug B is obviously going in this random direction and it's at a value of 50 newtons worth. So what we want to know is its X and Y components. We want to know how much that relates to on this and this scale. So quite simply, all we need to do, change colour to make this a bit more obvious, is drop a line down there which creates a right angle, and with a right angle triangle we can work everything out. So we're going to work out the X component to start with. So what I'm going to do is just recreate this as a nice little simple triangle. There's that simple triangle, and there's our right angle that we've created. Now what do we know? We know this value here. I'm going to put a little alpha in there. And alpha, as we've been told, is 25 degrees. We know this distance here, as we can see that's there, 50 newtons. So we know that's 50. So what we need to find out now is one of our other sides. So to start with, we've got our alpha. We always, when we're doing a bit of trigonometry, look at where the angle is and look at where all the other sides relate to it. So opposite that angle is this side here, which we'll call O for opposite. Alongside this angle, we'll call A, which is for adjacent. And then always opposite the 90 degrees, which is conveniently the longest line, is the hypotenuse. So now what we need to do is look at what do we know and what do we want to know. Well, we know the 50. We know the angle alpha. What we want to know, what we don't know, is this X component down here, okay, which is our adjacent. So we know the H, we know the A. And now what we need to do is work out how to do it. So if we remember our special word, so, ka, toa. We know A and H. That's O and H, that's no good. O and A, that's no good. A and H, there. So to write this out in full is cosine of alpha is equal to adjacent over hypotenuse. So the cosine of alpha being adjacent over hypotenuse, now what we do is populate what numbers we know into that formula. We know alpha is 25 degrees. So we can write cosine of 25 is equal to A over H. We don't know what A is. We know what H is, there it is for our 50. And that gives us now cosine of 25 is equal to A over 50. Now using our magical transposition, we're going to shift the A onto its own. So to do that, we're going to multiply both sides by 50. Because it's been divided by 50 here, so we always do the opposite. So we multiply just to get rid of it. And then obviously we do the same on the other side, so we've multiplied by 50. So it's 50 times the cosine of 25. And to swap it round, now what we're left with is A. So we've got A is equal to 50 times the cosine of 25. And I can just tap that into the calculator. So what I'm going to do on my calculator, I'll have a button that looks something like this, cos. And some calculators are different, but what we're going to aim to do is just type in 25 on the calculator, then type the cosine button, and that will give us a number which is 0.906. So it's 50 times by 0.906. Okay, I'll just put it in brackets so you can easily separate that out there. And then 50 multiplied by 0.906 gives us our value for A which is 45.32. So we've got one side. A there is that sign there, which is the X. Okay, and then we'll go in the next clip, we'll work out the other side.